Good morning. I'd like to introduce David Coghlan, the president of Havok. He joined at Grand Industry Havok. He joined in 2004, 2 years prior to Intel acquiring us. He is in charge of all leadership roles, strategic direction, involved in the simulation growth for the last 7 years, which is kind of watching us grow that market. And introduce David Coghlan.
Thank you very much, Scott, and thank you very much for being here. It's my honor and my pleasure to be here to talk to you today. As Scott mentioned, I'm the president of Havok, which is the games technology and 3D simulation wing of Intel Corporation. And what I'd like to talk about today is the role that game technology can play in the landscape of simulation technology. So I'm acutely aware that I'm standing here today talking to the industry in the midst of a very challenging time. The budget cuts have reduced overall spending in general, and in particular on training. And at the same time, I think there is a clearly recognised increased need for warfighters to be more multifaceted and to be trained in a broader range of tasks and responsibilities. And defence forces must increasingly look to simulation for mission training, for rehearsal and decision support. But simulation technology itself is undergoing a significant transition, an evolution to meet the evolving training needs for a diverse range of operations. And the question I'd like to explore today is what role game technology can play to assist in this evolution. So what I'd like to do is look at a critical assessment of AAA games technology, in particular, the role it can play within simulation technology. From a Department of Defense perspective, it's not necessary to license or even fully use this technology directly, but I think it is very important to be aware of the capabilities of key game technologies out there, because this will help inform what type of training scenarios are possible and what's possible in programs that you're defining. So my focus today is going to be on AAA games. I mean, clearly the games industry is a broad industry that runs from everything from $1 apps that can run on a phone right up to high-budget AAA productions. And I'd like to focus on the AAA side in particular because while there are 2D non-real-time games that can be useful for simpler training applications, it's really in the arena of 3D real-time games where I believe there's most applicability of game technology within the simulation space. And it's also when I'm most qualified to talk to, because these types of game productions are the ones that are Havok's customers day to day. So, if we go to the next slide there. What I've seen over the last 7 years, working with simulation customers and attending simulation trade shows, is that there's been a significant evolution in terms of how game technology is perceived and used within the simulation space. And I think the initial phase that we began to see was a situation in which there was some emergence from the skepticism and the perception that really mirrored mainstream perception around games. Games were considered fun activities for kids. They were generally regarded as frivolous entertainment with marginal merit in the real world of simulation and training warfighters. At the same time, the simulation industry and the technology there was actually doing a very good job of meeting some of the key training needs of the sector very well. When it came to high flight, fast jet, ballistics, the technology there was meeting those needs quite well. But I think there was a growing need to look at virtual simulation for training beyond this, and this is where, when you began to move more toward ground-based operations, that the technology was struggling more to match the training needs. So whether that was, MOUT, small arms trainers, operation trainers, common driver trainers, I think what we were seeing during that phase was that the technology landscape associated with historical simulation wasn't really aligning with the needs sufficiently. So, I mean, over time there was a growing awareness that AAA games were actually large, professional, well-run projects with a huge emphasis on innovation in the technology around 3D visualization and simulation. And also over time, I think senior military officials were becoming aware that becoming aware of the AAA games played, not just by their own kids, but by the young men under their command. And they could see that visually there was a discrepancy between what they were seeing in those AAA game environments and their own simulation environments. So to just give an idea of where sort of the state of the art is on these AAA games, I'd like to just show an example from one of Havok's customers, EA, which is a title called Battlefield 3. So clearly the visuals in this title are very impressive. It's also leveraging Havok's physics and destruction technology to add dynamics to the scene that you'll see in a moment. And I think the point here is better visuals are nice, but it's not enough in itself to warrant a switch in technology. Just because troops are complaining that the sim doesn't look as good as the game that they're playing in the rec room, that's not enough of a compelling reason to switch, as long as they're getting adequate value from the simulators. But I believe that gaming technology can genuinely increase training value over legacy systems. And that's really the second phase that I think we're in at the moment around how game technology is being used to unlock some of that value. So I'll just play out the video here and you can see some of the physics and destruction technology being used in a scene here. So really, I suppose the phase we're in at the moment, I think, is one where game technology platforms are being adopted, and there's broader acceptance in targeted areas. So I think the existence and the attendance at the Game Tech conference is a testament to the fact that there's broader awareness of the need to consider game technology when thinking about best practices around military and simulation training. And I think in this phase that we're in at the moment, what we're seeing is the defence sector licensing individual games and game environments and tailoring those to specific use cases and training needs. Building out content and exposing tools for training scenarios to be built and run within those game environments. And I think that's a really good first step in proving out the value of games-related technology within the simulation arena. And I think what we're seeing at the moment is technology is being built with a specific use case in mind, a variant of the game that they evolved from. But I think there's still relatively closed systems at the moment, what we're seeing, rather than true technology platforms that might be more common in AAA games. So I think already the simulation industry is pushing some of the capabilities of the current verticals that we're working with to the limits. And as we move to require simulation in larger scale environments, joint operations at multiple altitudes, or even just more dynamic environments, I think some of the ways in which games technology is being leveraged today are going to start to break down a little. So, I see where the industry has got to with regard to adoption of game technology, and I think it's a really good start, but, I think it would be a huge missed opportunity if the game industry was to, in the face of the current budgetary pressures, was to sort of stop here, and call the adoption of game technology done. And I think, what I'd like to, paint a picture of today is a next phase that, that even against a backdrop of fiscal constraint, there is an opportunity for the simulation industry to leverage game technology to bring a huge acceleration of value. Next slide. So I think the next phase that we can see would really be about the adoption of open game technology platforms that can be integrated into an ecosystem of simulation technology. Leveraging games technology as a difference maker. Go to the next slide there. A difference maker to enhance the training value in simulations and to reduce the cost of simulation training, deliver projects on time, on budget. And I think then the side benefit of that is that you get the high-end visuals for free, but that's not the prime motivation for moving toward a technology platform like this. The prime motivation is actually enhancing training value and looking at game technology as a method to bring projects out on time and on budget. So, I mean, personally, from my point of view, I'm really convicted about the evolution to this next stage, about the emergence of stable software platform and an ecosystem that promotes reuse, that reduces risk, and enables new training possibilities. And as Scott mentioned, I've worked with Havok for over 9 years, but I took over as president of the company 3 years ago, and one of the first things I did was go to the Intel board of directors and make a case for a long-term investment that Havok would make in this space. I'd seen the impact Havok had in the AAA games industry over the last 12 years, and I felt convicted that companies like Havok and others on the game technology side could genuinely make a difference in the simulation side. So on the Havok side, I pitched and received full backing for a long-term investment plan by Intel and Havok to make this a reality. We created a dedicated division and R&D team focused on the military simulation sector. We've gone on some acquisitions in support of this. And overall, even against the backdrop that we're looking at today in the budget environment, we're very pleased with the progress that we're making here. So, in order to consider how this AAA games technology can be a difference maker within the simulation arena, what I'd like to do is just look under the hood a little at what a typical AAA game production looks like. Think about the scope of the project, the budget of the project, and what are some of the key things that the designers of these games care about, and then consider those about how they map to the needs of the simulation industry. And in order to do this, I'll be drawing on Havok's experience. Just go to the next slide there, of working with game teams and simulation companies. And even within the military genre alone, if you look at some of the franchises that Havok has worked with and where our technology is incorporated today, it's really a who's who list in terms of the key military genres of games out there at the moment. Call of Duty franchise, Medal of Honor franchise, SOCOM, Battlefield, Operation Flashpoint, and a whole range of other, and that's even just within the military genre alone. So what I'd like to do is just go to the next slide there. Just think about the primary goal within games. And the primary goal here is really one of entertainment. Driving player engagement is a key question. And there's two questions that game producers generally ask themselves as they're building out a title. The first is the game fun? Is it varied? Is it addictive? And I think for the simulation space, that really shouldn't be that relevant. Training time is mandated. You're trying to deliver a realistic training experience. You're not trying to entertain. So I don't think that's a relevant question. I think that element of what games are trying to do should be set aside. But the other question that game producers ask themselves is a game immersive? Is it realistic? And I think this is a much more interesting question for simulation. An immersive environment will grip the player more, will draw them into the simulated environment. And a realistic environment with high-quality visuals, with plausible dynamics for avatars and vehicles is a very rich environment for 3D simulation and training. Players, in games will face a choice of decisions and actions. The decisions and actions drive outcomes. And that's one of the things that separates real-time interactive experiences from movies. And the broader and less constrained that choice is, and the more directly related and consistent the outcome that is driven off those decisions, the more engaging the experience is. This is a question that game developers ask themselves all the time as they're looking at the project, but I think it's also one that's very relevant to the simulation space. So we just go forward to it. So when you consider a typical AAA game, what I'd like to just look at is sort of the overall scope and budget of one of those games. And the reality is what you're looking at with these games is development and production budgets that often lie within the $30 to $80 million range. They have development cycles of 18 to 36 months. The credit roll on many of these titles runs to about 500 people, which is a daunting prospect. But I think when you cut through that and cut out things like voice actors and everything else, you're still left with a core team of about 100 to 200 specialists, programmers, artists, and designers. So On the face of it, if the ambition of the simulation industry is to try and deliver an experience similar to the Battlefield 3 experience that you saw there, that's a daunting prospect. You know, that's already far more resources than I think you can expect to put on a typical program. But I think there's some good news, you know, for the simulation industry underneath that. So the reality is in games, an awful lot of the spend is on content and on unique content. Games are trying to create a unique artistic experience, and just as Hollywood directors with each movie will want it to have its own vision, they won't reuse props, costumes, or sets. The artistic side of games has an inherent drive to try and deliver something unique with each title. Good news is in simulation, you don't have to care about this. When you're, you know, if you look at the Battlefield 3 title, for example, there were 24 people on level design and environmental art. 25 people probably for the full 2 to 3 years of the project. In simulation, you can work with satellite imagery, with terrain databases, you can instance geotypical buildings in a simulation to create appropriate environments for simulation at a much, much lower cost than the AAA games industry can do. And similarly, if you think about the dynamic entities within a scene as well, for your vehicles and for your avatars, while games generally won't want to reuse those, they will want to create unique models each time, unique characters each time. If you do intend to reuse, and you know in advance that you can reuse those models and those avatar models, you can significantly lower the cost relative to games by making technology decisions early in your pipeline to maximize the reusability of that content. We just start the video there, Dan. So this ability to get content into a simulation in a cost-effective way is something that Havok is very convicted about. It was actually a key driver in our acquisition of this company here called Rocketbox Studios last year. And I suppose, you know, the key takeaways from looking at this is that, you know, if you look at characters or avatars, a bulk of the cost actually in AAA games is on the animations rather than the rigs themselves. But if you could build if up front you can carefully build a standardized rig like the Rocketbox one here, this allows you to reuse animations, to use a range of attachments like weapons and different configurations, to layer and reuse facial animations. And you know, if care is taken as well during the character mesh generation stage, that allows you to lay out texture coordinates in such a way that you can make it trivial to swap insignias to layer effects like wounds, damage, dirt on every character. And I think that's just an example of how the simulation area can come up with visuals that are very, very close to AAA game quality, but at a significantly lower cost because of the fact that you don't have this constant backdrop of wanting to create unique content each time. And the other good news is that, you know, in the simulation space, you have access to much of the same technologies that the leading game companies use today. If you go back 10 or 12 years ago, companies like EA and Activision, their technology was largely being built in-house. It was proprietary. Even if you wanted it, you wouldn't even be able to get your hands on it. I mean, the reality now is that there's a much more mature ecosystem of third-party providers, and that now you can indeed get access to the same or equivalent tech that the leading AAA games can use, and you can get that from third-party providers. So, I mean, while the games industry itself is big business, and it is undergoing its own challenge right now, competing against $1 and $2 apps on a phone. And as a result, the industry has been very focused over the last few years, in particular, on how to deliver rich game experiences, but for less money. And you know, in Havok's case, we've worked closely with the games industry to help them deliver projects on time and on budget, and look at ways to carefully manage these large production budgets. I mean, while to the end consumer, Havok is best known for the high-end visuals, the physics-based gameplay that they see in the titles, I mean, the reality is, you know, under the hood, at least half of our technology portfolio is dedicated to helping studios manage production costs and get projects out, you know, on time and on budget. So Havok, and indeed many of the other companies that you'll see exhibiting here at the show on the game side, are providing tools for games with, you know, very effective WYSIWYG development environments that improve iteration times, that provide excellent profiling and debugging capabilities for 3D programmers and artists. And the tools are really very mature relative to bespoke simulation counterparts. And the great news is that that technology is fully available to the simulation industry. The other thing is, you know, when looking at AAA game technology, you're looking at what's genuinely a proven technology base. You have an ability to leverage technologies that have been proved out time and time again in projects with $50 million budgets plus. And that can give you a degree of comfort in terms of leveraging that technology. But there's also a huge pool of experience to draw upon there. If you just consider the current generation of consoles alone, for example, with, let's say roughly 1,000 titles released across PlayStation 3 and Xbox 360, that's about 50,000 man-years of innovation and experience on the engineering side around virtual 3D technology that you can draw on and you can look at. And these are well-run projects, they're carefully planned, and the industry is refined to figure out which companies and technologies to use, which can best assist, and you could directly benefit from this rich pool of innovation and experience. It is worth noting that within the AAA games industry, what you do see is much less use of open source or free technology compared to some other software arenas. There are some standards like OpenGL, but there's much less use of actual open source technology. And this is something that I think the industry has learned over time, where some of the short-term savings associated with saving license costs on open source technology can ultimately prove to be short-term economies of scale. That over time, the benefits of working with professional companies can actually reduce costs much more in the longer term. Advantages include lower maintenance costs, more robust documentation, much better technical support and training, and an ability to benefit from the ongoing innovation that the companies here at GameTech and indeed many other companies targeting the technology in the AAA game space will continue to focus on. So the next thing I'd like to look at is just the overall hardware environment in which AAA games need to consider. And game technology was really designed from the ground up to run on resource-constrained systems. If you consider the leading games of today, they're designed to be played on an Xbox 360 or PS3. And that's hardware that's actually 8 years old at this point. It's not, it's far from cutting edge. And even at launch, it was designed to be inexpensive. It was actually less powerful than a cutting edge PC at the time, because the idea was this was something you could buy for a few $100 and put on your living room, put on a TV in your living room. So, the games industry has actually made a critical success factor of getting maximum performance from these constrained hardware systems. You can't, within a game, you can't simply throw better hardware at the problem. You can't throw more hardware at the problem. You can't take more time to do the compute because it's fundamentally, a real time rather than an offline process. So, the games industry has been sort of asked by the consumer to deliver graphics that compete with Pixar or ILM or the things they see in the movies, but the reality is they're doing that with a fraction of the compute power, not just on the hardware side, but the amount of time given to render and to simulate each and every frame in real time versus what's done as an offline process in the movie industry. So, that's good news for simulation, because as a result of this huge optimization that the industry focuses on, out of the box, these technologies often perform really, really well on standard PCs. The results are richer scenes with more entities, more detailed graphics, running on the same systems. And a game-based IG is often efficient enough to run not only simulation and rendering on the same machine, but in some cases multiple IG channels plus the simulation, all on a single PC. And this reduces hardware deployment costs and can save programs money. The other good news is that games technology is typically optimized across the full range of latest hardware, and it's optimized really to support all the hardware requirements that, as the simulation industry, you need to care about and think about. It might necessarily have been the case. It could have been that games were played on Game Boys and simulation was done on Silicon Graphics dedicated hardware. There could have been more of a discrepancy. But the reality is, any of the platforms that games are focused on today, from handheld to tablet to laptop to desktop to server, all map directly to the type of hardware processing platforms that the simulation industry needs to care about. And I think that's good news from the point of view of thinking how that technology can be leveraged. So what I'd like to do next is just move on to the visual aspect of games. And visuals are clearly a large part of what game productions are focused on. We can consider a few elements of visuals when thinking about its applicability to simulation. The first, I suppose, is just pursuing photorealism. Making the still screenshots in games look photorealistic is a large focus. But it should be borne in mind, AAA games are generally trying to emulate one particular sensor. And that's the film-based movie camera. So they spend a huge amount of time emulating what are actually artifacts associated with this sensor, because they're trying to mirror what we're used to seeing in movies. And they will spend time on tone mapping, depth of field, bloom, lens flare, things like this, to try and mirror the Hollywood-style experience. Now, there's some very expensive rendering solutions out there, and if you put them in the hands of a large team of talented artists, they can certainly get Hollywood-style screenshots out of this. But I'd argue that the simulation industry doesn't need to go for hugely expensive game renders. You don't need still shots that would make the cover of a film magazine. You simply need to be realistic enough to deliver training value. And I think your priority in selecting a game-based IG should be looking at renderers that are open, flexible, and modular, and allow the system to easily render, based on sensors other than the movie camera. That can, primarily be the eye, but also other sensors. We just start the movie there. So, Havok's own rendering engine, the Vision engine, is one example of an open system like this, and indeed there are others. But a third-party COTS company called JRM produced an excellent range of real-time physics-based sensors. And JRM are a partner of Havok, and were able to integrate with the Havok Vision engine in a very short space of time, bringing these simulation-grade sensors plugged into a game rendering environment in a very short space of time. So I think when considering the visuals within games, it is important to acknowledge that difference between what AAA games are trying to go for with emulating the Hollywood style experience, and the types of things that you need at the level within the simulation industry. Okay. So the other critically important aspect of visuals in games is dynamic, and the still shots can look great, but I think one of the key questions is what happens when they're set in motion. And as a result of Havok's pioneering work, virtually every 3D game out there features a physics system. It's leveraged for core collision detection, rigid body, or Newtonian dynamics, and constraints. But once implemented, you actually get an awful lot for free. You want to start the video there? So you get line-of-sight queries, you get physically enabled vehicles that go way beyond clamping, you get dynamic terrain, you get realistic destruction. And I like this example because it's a good example of emergent behavior that can just come out of having a physics system underlying your 3D visual environment. So what we're looking at here was an example of a demo that we put together showing a vehicle following a specified path within the scene. So Dan's just calling that up now. But what I like about this demo is that it shows dynamic terrain, but it wasn't specifically implemented in any way to design that. It was actually intended to show the vehicle following a path, but one of our field application engineers was asked a question about dynamic terrain. And within the tool, he simply called up the terrain editing feature, which was normally intended to be done as an offline process. But when he started modifying the terrain, the vehicle itself was actually accurately following the dynamic terrain as it shifted. And that's just an example of the emergent behavior that can come out of having a real-time physics system underlying your simulation. So, if you reflect on current simulation environments, the reality is, to a large extent, the environments today are static, and that can have implications for training value in terms of simulation becoming repetitive and predictable. And there really is significant training value, we believe, coming from a dynamic world in which your IG and your physics simulation can actually deal with dynamics like this. You can enable simulated environments to more accurately and realistically simulate the real world. You want to call it the description over there? What you can do is you can open up a broader range of tactical decision making for your trainees as well. So this is an example of Havok's destruction physics technology, showing very realistic building destruction. And this gives an example of the type of tactical decisions that can be opened up if you have a system like this underlying your simulation. So what you can do is deliver more accurate simulated outcomes as a result of training decisions. Ballistics create rubble, they can block movement paths, damage state, questions of cover in urban terrain become dramatically more realistic. And overall then what you're delivering is a real-time persistent simulation environment that provides consistency and that can be correlated between federated simulations. If we could. So that's an example of vehicle and environmental dynamics. The other element within visuals, whether it's 3D games or simulations, is realistic human motion is also very important. The human eye is very sensitive to discrepancies in human motion, and if visuals deviate too much from the expected behaviour, a sense of realism and immersion is certainly lost. And this is one area where games spend an awful lot of money on character motion, and the range of animation sets that are managed within games are very broad. I think simulation could never justify similar investment, but Havok and others are looking at ways to get technology into the hands of the simulation industry to allow game quality character motion to be populated into the scene in an inexpensive way. So we have some very mature tools and technology in the area of managing avatar and character movement. And the key is not just to have good source animation data by way of mocap, but actually the ability to blend realistically between those states. So in this example, for example, we took mocap data motion capture data that had been captured, and what Havok can actually do is, as a process, analyze that mocap data, extract the root motion of the character from that, and actually just build out an entire animation state machine that can be blended between at runtime to give realistic motion like this. And then we have libraries of content out of the box where you can get this type of game quality visuals, but at a fraction of the cost that game companies will spend creating this uniquely each time. Okay, so the other aspect of visuals to be aware of in AAA games is that, just like a Hollywood set, I mean, games can often cheat lots of things. And if in a Hollywood set you go behind the billboards, you'll see that they're not actually built. It's just a front there. And games can actually take a good number of shortcuts as well to deliver what to the player looks like a very convincing, very realistic environment. But actually, in many cases, what you think you're seeing isn't always there behind the scenes. So a good example is often the sky. I mean, if you look at the sky within games, you can see very realistic looking clouds and everything else. But the reality is that's sort of like the 2D backdrop within a Hollywood movie set. That's generally a painted skybox. The clouds may look great, but they don't actually have volume. And similarly, if you think about lighting and time of day, often game scenes will look fantastically good, will look Hollywood style, but they're designed specifically by the art team to look good at that particular time of day. And there was an awful lot of effort put into making the scene look good for that particular instance. You want to come down there, Danny? So, in the simulation side, I think you need to consider a more diverse environment there. You need to think about time of day, you need to think about weather systems where you have genuine volumetric clouds. So I think that's just one of the things to bear in mind when stacking up what you're trying to do relative to AAA games, is that in some cases you won't have the luxury of being able to cheat some of these things. But I think the good news is that I think there are good technology solutions out there that can solve some of these pieces. And in Havok's case, our approach, for example, here with the volumetric clouds that you're seeing has been to partner with a company called SimulWeather that focuses on volumetric clouds, and we've been able to incorporate that technology into an open games technology platform relatively simply, to implement that. Similarly, if you look at things like ocean rendering as well. I mean, as we've worked with maritime customers, I call that example there. As we have worked with customers targeting naval use cases of the technology, what they've needed to look at is things that deliver the training value that they need within a scene. So, for example, the operators in this case would actually look at the wave breaking in the bow of a ship as actually a visual cue in their training. They would need to look at the weight behind the ship as part of what they needed. And I think these are some of the things that the simulation industry will need to consider at a level beyond games. But I think the good news is I think if the game technology environment is open, then these type of things can be layered on top of a game technology to really deliver the things that are important for training value within the simulation space. So when you bring all this together to create a realistic environment, you have realistic avatars, vehicles, terrain, environmental effects, whether that's weather or time of day and that side of things, you start to get quite a compelling visual environment in which to operate. But there is another important consideration that the simulation industry needs to deal with, and that's the question of scalability. Just jump forward there. So, I mean, if we consider differences differences between let's say, for example, a range of use cases, whether it's from fast jet to UAV to tactical helicopters, ground-based vehicles, dismounted soldier training, small arms trainers, cultural trainers, naval trainers, joint operations. I mean, the implications within each of those training environments for the amount of scale, the content fidelity, the coordinate systems you need to use, but a physics-based environments is important. Need for dynamic terrain, question of support for multi-channel. The answers you get when you think about each of those use cases can be quite different. And to date, the approach in the simulation arena has really been to build customized solutions to solve each of those use cases in isolation, which can be fine, and it has effectively solved the use case in isolation. But I think the key really to look at ways in which game technology can be used to help manage cost and productions going forward is actually just to reflect on the sunk and hidden costs associated with this approach. So if you consider piecemeal building solutions to solve each of those cases, there's the technology development cost or the technology acquisition cost in each case. It's significantly costly in terms of one-off engineering work to integrate disparate technologies to communicate in a federated simulation. There's a different content pipeline for each use case. There's a cost of training scenario developers. And there's a challenge of transferring people and knowledge between projects. So, I mean, for games, when it came to scale, it used to be common wisdom that game environments were just way smaller than typical simulation environments. And that certainly used to be the case. If we go to the next slide there. The visual you're seeing in the top left-hand corner there is GTA 3, which in 2000, that's Grand Theft Auto 3, which in 2001 was described as an open world game. It was a major advancement in terms of map size. But, and it featured an environment that was considered huge at the time. It was 3 square miles of city terrain. And this has really evolved an awful lot over the last 12 years. So, for example, Just Cause 2, which is a title where Havok worked with the developer to put in place a huge map, 400 square miles in size, with an awful lot of detail of that map, down to the level of, down to the level that an individual first-person or third-person view would see. So, I mean, I think that the scale, when it has come to AAA games, has evolved an awful lot over the last 12 years. But I still think it's not at the level that matches the needs of many of the training scenarios that would be considered on the simulation side. But I think that's continuing to evolve going forward. And what we're seeing is if you have a visualization system and a physics system that can handle a reasonable breadth of use cases within the ones described there, it opens up huge possibilities for cost savings. So, for example, you may not get a system that does everything from high flight, where you care about curvature of the Earth, down to a first-person view where you need to be able to realistically see avatar animations, or right down to facial animations. But certainly what we're seeing with some of the early adopters of Havok technology, if you want to jump to the next slide there, is that scenario designers can actually look at a unified technology platform to deliver everything from use cases as diverse as tactical helicopter right down to close ground-based work. And by using a system like this, you have a system that will always have out-of-the-box content in terms of the libraries of content that are available. It will have real-time physics simulation always on. It will have cutting-edge visual quality. It has an import path for terrain and content standards, DIS, HLA protocols pre-integrated. And it's open to allow other content, COTS, and in-house technology to be added into the system. So, I mean, if you go back even a few years ago, having a standardized technology platform that could tackle, a broad range of use cases like that wouldn't have been something that was possible. And as a result, there's been significant spend on disparate systems and bringing those systems together. But if you can actually look at a unified technology platform that can address this and one that's open to allow other technology to be integrated into that, I think it opens up a significant potential for enhancing training value against a backdrop of budget cuts. And we're certainly excited by the results seen by some of the early adopters and some of the integrators who are using Havok's technology in such a way to replace not just a single system, but actually to replace a range of systems and have those available as they look at targeting specific programs, to have that full out-of-the-box capability of technology available to tackle that. And this isn't about going above and beyond requirements for particular programs, because the reality is the technology is there to be used, but depending on the specific use case, you may care about realistic facial animation, you may care about deformable terrain, you may care about the high quality visuals, and that technology is all available within a unified environment to be used, by the teams as they target particular programs. So what I described sort of at the beginning was an overall evolution of the way in which game technology could be leveraged by the simulation industry. And I really think, looking at the third phase that we're moving into next, I think there is a very strong case that game technology platforms can assist in reducing the cost of simulation training. They can help deliver projects on time and on budget. I'll start with the training value element. So I think they can enhance training value in simulations by enabling simulation environments that more accurately and realistically simulate the real world, and enable a broader range of decision making for the trainees, and bring together that real-time persistent simulation environment that provides consistency there. But also, that technology can help deliver projects on time and on budget. That's obviously a key consideration for the industry right now. And I think that can happen by reducing duplication of work, by leveraging that single system across multiple simulation use cases, improving the transferability of resources from one program to the next, reducing the cost of integrating those systems, enabling increased use of inexpensive off-the-shelf hardware systems, offering open architectures that integrate with existing protocols and existing COD solutions, and really future-proofing for advances in game technology. I think that's an important consideration here as well, is that it's not just about picking up a snapshot of where game technology is at today. Clearly, game technology, with the dollars behind it and with the focus on continuing to push 3D, is going to continue to innovate going forward. So, the ability for the simulation industry to tap into where the games industry is at today, but also then to benefit from all the evolution and innovation that's going to happen within that space over the next number of years, I think, can be really beneficial. But at the same time, I think you can see that taking that games technology and actually, moving it to support the unique needs of the simulation industry isn't actually that far away. I think that's where the next phase, is genuinely interesting, and can show the adoption of game technology as a difference maker, in training and simulation. So, against a challenging spending environment, just go to the last slide there. It's still an interesting time for the simulation industry. There's lots of scope for the state of simulation to evolve, and I'm certainly convicted that game technology can be a key difference maker in driving this evolution. I think there's a lot of very interesting talks and presentations at Game Tech that will help provide more insight into the role that game technology can play within the simulation arena. And it's a very exciting time for Havok to be participating in the space, and I and my colleagues are very excited to work with you to make this a reality. Thank you.
Start actually 10 to 10 break. We'll be back at 10 to 10.
I'll get this floor opened up with questions and see where it goes. Of all the comments you made in the exchange minutes, the one I find most interesting is the concept of going towards an open architecture. The industry, historically likes to have closed opportunities, which is proprietary to them, and then causes the government or the customer to come specifically back to them for particular enhancements. Can you expand a little bit about why you mentioned open architecture, providing a venue or a rail that allows everybody to play and yet everybody to benefit?
Yeah, so I mean, I think I suppose my comment was really designed to distinguish between the range games technology is being used, I think, today, which is to take specific game use cases and to tailor those and to add content and everything else, but that's still within, still a variant of the game in which it was originally built, compared with something like the technology ecosystem that exists within the games industry today. So it's still commercial technology, but it's commercial technology that's implemented with very open software architectures. It enables different systems to be plugged in together. There's a lot more source code availability. I mean, for example, when Havok ship our technology like the Vision Engine, we give 100% source code to customers, and we also provide APIs that allow other technologies to be plugged into that. And I think that's not uncommon. I think you'll see other middleware and engine technologies within the game space that are actually based on an idea of an open architecture. But they're generally implemented more as technology platforms rather than taking a specific game or use case, tailoring that game across. So, I mean, my view is that the next evolution can be a situation in which the simulation industry can actually benefit from some of these more open architectures. It's not that they're not commercial architectures, but that they're much more open, and that they provide more access to source code, that they provide an ability to plug in not just other game-based technology, but to be easily integrated with technologies that exist within the simulation industry, whether that's DIS-HLA or whether it's DISTI or whether it's terrain formats or anything else, that is providing much more open access there. And I think then that provides flexibility on behalf of not just the government but the integrators as well, to pull together the right solutions for the right project. Because I think one of the things that the games industry has learned as well is that one size doesn't fit all. It's about finding the right bundle of technology to solve these use cases, and having the flexibility to be able to plug and play the right technologies to deliver that use case, I think is where the games industry has seen success.
Other questions?
Yeah, I've got a question. Pete Morrison from Bohemian Interactive. I mean, I'm very curious about your three phases, and that you're arguing that we're not yet in the third phase, that this is still to come. I've been involved in this industry and in this particular conference now since 2008. And I mean, I've seen this happen, since then at least. Darwin's Ambush 2004, that's when it really began. So I think it's kind of curious that you're saying to this audience that we're not there yet, and I think you're doing games a disservice by making that argument. So I'd like to kind of hear you elaborate around this three phases.
Yeah, absolutely. Happy to do that. I mean, I think what we're seeing at the moment is we're seeing a situation in which game technology is actually being proven out as as something that can align with simulation. But I think where there can be an evolution to is something that represents much more open architectures. And I think that's something where the AAA games industry has moved toward at the moment. Situations in which there's a whole array of middleware and engine systems that can be, as I said, plugged together for specific use cases. And I think, if we look at, where the simulation industry usage of game technology is today, I don't think it's at that point. I don't think we're at a point where the flexibility of moving content, of integrating other COT solutions, of integrating other technology solutions, I don't think it's at that point of leveraging genuine technology platforms rather than leveraging a specific game use case.